Morning. I'm Rob McClary. I'm with FORTRUST. We're a data center out of Denver. Looking for the clicker. Okay. So I'm going to talk to you a little bit this morning about the evolution that we went through from a traditional raised floor model of data center design and construction to a more of a prefabricated modular design. And this this process took a little bit of time, actually over 11 years, and kind of go through some of the changes that we went through in evolving our paradigm. So, just a real quick show of hands, how many people here like classic cars? Okay. I'm going to try to give you a little bit of an analogy on how we shifted our paradigm, and I'm going to at least show you some cool car pictures. So we'll loosen it up a little bit, hopefully loosen me up a little bit. I had this quote that was given to me probably about 2 or 3 months ago, and I looked at it and I thought, wow, you know what? That's I've never heard it before, but it was a statement about when a paradigm's replaced by a new one, albeit through a complex social process, the new one's always better, not just different. And I thought to myself, I said, wow, that's kind of the process we went through. My definition of a complex social process is pretty much people getting together and collaborating and getting the end user involved with what you're doing. And it certainly was true in our case. So, according to the 451 group, there's four factors driving the business and the technical transformation of the data center. The first being financial, second being speed, third being reliability, and fourth being efficiency. And as we were going through this process, we actually found out that all four of those things were very relevant and very true on why we were driving to do something a little more efficient, a little quicker, and so forth. So to give you a little background, FORTRUST is in Denver. We designed and built a 240,000 square foot multi-tenant data center, 2001. Opened for operations actually the day after 9/11, which was interesting. We spent probably over 11 years in what I say 3 significant attempts at evolving our paradigm. And each one of those attempts was timed with expanding our existing facility. Some of the results we've seen in 2012, once we actually went to a more modular design and delivery of data center capacity, was 5.2 megawatt at 2N increase in critical load to the facility without ever moving a wall, without ever moving or physically expanding the facility itself. We managed to get a 14% reduction in capital costs of construction, including soft costs, 29% reduction in PUE, and we've estimated that we should save about $800,000 annually in power costs. And kind of a byproduct, we had a substantial increase in ancillary space. What I mean by ancillary space is office space, storage space, space that you don't get a lot of in a data center, but customers or end users, IT end users, ask for and talk about quite a bit. So our original raised floor design had 6 different phases. We built them out incrementally, meaning we didn't build the whole facility out in 2001. We built it in phases. And every time we would go to expand our phase or to the next phase, we'd try to get a little more efficient, try to reduce some costs, try to increase the density in the data center each time. Once again, I call it opportunity to evolve our paradigm. So when we started out, we had about 110,000 square feet, traditional raised floor, 36-inch, throughout all 6 of the phases, would have yielded 11 megawatts of critical IT load at 2N. Standard 100 watt per square foot design, 6 different co-location rooms in the first few phases, and whatever we were going to fashion going forward. So, traditional raised floor, our environment, and that's kind of one of our rooms when we built it. And we call it Data Center 1.0. So I thought, well, it's the classic data center design. If you're familiar with the Shelby Cobra, you'll see that it was built with a lot of power and not much thought to user benefits or creature comforts. In fact, if you this car here, you know how you air condition this car? You step on the gas. So over the years, when we would go to expand our data center, we were always looking to do 4 things. Increase the critical IT load to the IT end user, create higher efficiency by lowering our PUE, and when we started with that original design, pretty standard in those days, we had above 2.0 in PUE. We also wanted to reduce the capital expense of construction and optimize the physical square footage we had available, whether that was increasing the amount of raised floor or ancillary space that we could use within the data center. And each time attempting to evolve our paradigm. Some of the design concepts that we went through were redesigning the central cooling plant. We looked at everything from main air handlers, evaporative cooling, heat wheels, and we got to the point where we were doing so many design iterations, the only way we could keep up with it was to nickname them. So we had nicknames like Big Fan, Little Fan, and every time we'd present it to our ownership, I'd have to explain to them, oh yeah, this is the Big Fan design iteration, and then we'd go on to the next. Some of the due diligence that we did during those times was pretty much what everybody does. Tours of other data centers, participation in events like this, and by the way, I forgot to thank the Uptime in 451. This is a great event. The collaboration here I think is phenomenal. And we participated in events like this, looking at new technologies. But every time we would get to a better design, it normally got dismissed because the return on investment, the CAPEX was too high, return on investment or rate of return was too slow. It would impact the existing operations and possibly the IT end user, and the ever-present, if it's not broke, why fix it? So, when we went through our first expansion, we actually added 33,000 square feet to the existing facility, phases 3 and 4, as you see there on the screen. Increased the critical IT load to 4.8 megawatts, but our estimated design PUE still about 2.2. So really, what we did, we made a few user-friendly changes, but we stuck to the classical design. But we did manage to put a roof on it and some air conditioning in there. So, second time, we had a little extra time on our hands, and we were getting ready to expand another 33,000 square feet in the existing facility. So we had a little bit extra time, and we thought, well, man, there's got to be a better way. So we took a little different approach. And what we did was we decided, well, how about if we take the classic design and make some cool modifications along the way, try to drop that PUE down, and at the same time, increase the KW on a per rack basis to the IT end user. So, one of the things we did differently is we got IT end users involved in the process. And in our case, we're a data center provider. So that, in our case, is our customers. And we sought additional information from data center operators, people in the industry, engineering firms, contractors, vendors, But what we decided to do was develop a owner's project requirements document, what we called an OPR, and I'm sure you're familiar with it. It's certainly not anything that we did that others haven't done. But we took kind of an approach that said, let's start with our IT end users first, get a list of things that they wanted to see in the data center, and then kind of work our way through the process. So we had a lot of input from our customers, and really it boiled down to some of the significant ones. They wanted to increase the rack per kW instead of having to spread out. Increased in cabling for them, just made it a little harder to manage. A lot of them were going to blade servers, that sort of more denser IT equipment. They wanted more efficiency, but not at the expense of reliability. So everybody wanted to see us become more efficient, but they didn't want it at the trade-off of any sort of reliability. Capacity and space delivered on demand when they needed it. And in a data center, a lot of times you have to spread people out so they're able to contiguously expand over time. They also wanted ancillary space, work area, storage, office, all kinds of things. And they also wanted us to stick to our core competencies along the way. So our reality boiled down to this. How do we provide more kW to the IT end user, increased per rack density, and create efficiency? And that design document that we put together, the OPR, established 6 design priorities. And pretty simply stated, we didn't want to impact the current operations. The critical systems design reliability was going to be very specific, specific performance criteria that we were providing to our customers in the forms of service level agreements or SLAs. But we really wanted to increase the capacity, increase efficiency, and of course, like anybody else, we've got budget considerations and limitations. So we also put in to this OPR some key project requirements. So ways to measure, like a checklist, our success along the way. So we wanted to reduce the current design PUE from 2.2, and we had a goal of reducing it by 30%. And that's a pretty big stretch, it really is. But we wanted to put it out there for a target we could shoot at. Deliver on the RSLAs to our customers, plus at that time, some new ash rate guidance. Optimize the use of the existing building, reduce the CAPEX for construction, and what owner doesn't want to do that? I mean, that's pretty standard. But one of the things we had put in there was create a modular and incremental build sequence. So we didn't want to build it all out completely. We wanted to be able to do it incrementally, so in case we came up with any other improvements, we could fit those into the design as we went. So somebody said, well, hey, why don't we think inside the box? Essentially, let's take a look at containerized, modular type technology. I like that slide, by the way. So our first look at modular and containerized technology, we went through and we looked at a lot of different products out there. In fact, we used the 451 Group's report on the evolution to Data Center 2.0. And we started looking around at something that we could possibly put in our design. And what we found was there was a lot of great products out there that had all kinds of good benefits, but not all of them met our business model, being a service provider, and not all of them fit our paradigm readily or easily. So we decided, so let's have a design contest. Let's get everybody involved. Let's get some engineering firms involved, give them our owner's project requirements document, and see who could essentially come up with a better design using our current infrastructure. So at the end of it all, we came up with a design, and of course we had to have a nickname. So we called it the big vacuum. And we had actually created in phase 6, as you see, a central machinery corridor. We were going to do some hot aisle containment, a floating hot air return plenum, and we were actually taking a pretty significant bite out of our PUE. We estimated we would get the design PUE from 2.2 down to at or near about 1.8. So, as you might imagine, we called it our attempt data center 1.25. And it was really a classic model with some cool modifications. And we were all pretty happy with ourselves. Excuse me for the slides. I know I went a little overboard, but one of the things, going back to that quote, a complex social process. So what's a complex social process? Well, I think it has to do with getting a lot of smart people in a room, getting a lot of input, not only from the IT end users, but technology manufacturers, and really creating a collaborative effort. And I got to hand it, our construction team, the folks here on this slide, helped guide us through this process. And imagine, a bunch of engineers, general contractors, subcontractors getting together. There's a lot of ego, and there's a lot of different ideas, but there's a lot of wanting to do what's comfortable. And I got to hand it to this group of people. We really got outside our box on a lot of different occasions. So we were happy, had the design documents ready to go. We had a little time before we had to start construction. This is November 2011. If any of you have been to Denver, golf season starts to just, pan down about that time. I was actually had the opportunity and was invited to I/O in Phoenix. Well, we're a competitor of I/Os. And I thought, well, why on earth would they invite me down there? So I asked my boss and said, hey, they wanted me to come down and take a look at some stuff. And I thought, well, I can go play golf, if nothing else. So I went down to Denver and was introduced to I/O's modular platform. And even though we had looked at a lot of different things, this one here was kind of IT end user friendly, which fit our business model, being a service provider. And I thought, well, you know what? This may work. So when I got down there, some of the first impressions I had was, well, walking into one of those, the hot and cold aisle containment was easy, nothing was overly complicated, and it was pretty easy to see that it was purpose-built for the IT end user. And traditional raised floor environment has always been flexible. That's what made it, and I think that's what makes it still relevant out there from a usability standpoint, but the reason we haven't changed was because of the flexibility it provided. The technology in the data module wasn't complicated, and we had a operating system that we could integrate with our existing DCMI system. So it fit our business model, but what about our paradigm? So this is kind of a tough conversation when you go back to your ownership and say, yeah, we just spent a good bit of money and time on designs for our next expansion, but I'm thinking, we might want to look at this. So here we go again. Third time, maybe it's a charm. So some of the hesitations we had right off the bat, how do you take a risk on a new technology? That's always in the back of everybody's mind. Once again, that old adage of if it's not broke, why fix it? Our initial capital requirements estimates came in 20% higher than the design we had just got done paying for and actually creating. And so it was really hard to get past the economics right off the front. So we decided, well, you know what, let's take a look at this, build a TCO model, and make sure that we're looking at it the proper way. So once again, complex social process. And this is what I look at as the key, 4 main keys to what helped us get past that paradigm, the traditional raised floor paradigm. A little bit of letting go of ego, the collaboration that was involved, developing the TCO model, and ultimately adjusting our design and construction methodology. So imagine a lot of engineers, contractors in a room together, a little bit of ego. It's tough sometimes to get past some things. But one of the things that helped us along the way, I/O allowed not only our FORTRUST operations teams to come down and take a look, they actually allowed our whole construction team down to actually look, feel, touch the manufacturing process, the way they deployed the modular technology. We had some executive level management at pretty much every step of the process. We ended up actually flying our whole team down there. But one of the things that we did is we figured out how to adapt our infrastructure to accommodate the data modules. And this may seem pretty simple, but really we found out the key was design from the IT end user experience back. Most data centers are designed from the utility, MEP, down to the IT equipment area. We really had to take an approach of, okay, our IT end users are telling us they want this. The data module fits part of this. So how do we design and adjust our infrastructure to actually adapt to what we wanted to provide? So the other thing, you got to get past that financial piece. 20% higher than what we were going to design doesn't play. Doesn't play in the boardroom, certainly doesn't play with my boss. So we went through, now knowing, having gone through that collaboration, that effort that we took by taking the construction team down to Phoenix, taking a look at this, we were able to put together a new TCO model. And as I showed, I'm just going to summarize some of the things. On the CAPEX side, we actually took that 20% and reduced it down to 14%. So now the capital is less than what we would have built with our design, our data center 1.25 design, and that not by a little bit. It was a pretty significant decrease. We now can deploy our capital in a more incremental or granular approach. It's no longer building out 15 or 30,000 square feet, 3.5 megawatts of power, and then having to fill it with IT end users over time. The OPEX model, and this was compared with the same amount of capacity in our raised floor design as it would be with a data module design. So the comparison was apples to apples from a capacity standpoint. We were going to be able to reduce the PUE from 2.2 down to 1.57, 29%. And back when we put that goal of 30% in there, I thought there's no way. If we get halfway there, we've done something. $800,000 in annual power savings that we should see once the design is completely put in and the loads are there. So we also did a benefits and detriments analysis. This was key because at the end of the day, we're a data center service provider. And having that IT end user input, we also have to get past some perceptions. Benefits to the IT end user included increased per rack densities up to 21 kW across multiple racks. Greener technology, same reliability. We designed around our existing infrastructure, our existing systems, and basically adapted them to accommodate the data modules. Rack and equipment inside the data modules is agnostic. The customer can put in any kind of width, length, depth of rack equipment. it wasn't restricted to what they could use. And that's key from being a service provider. We can provide incremental data center capacity now in 60 days or less. We built 33,000 square feet in the traditional model, 19 months construction process. Enhanced physical security, and this was kind of one that we really didn't target. It was just out there, but it became very apparent. The raised floor now around our data module infrastructure is no longer an air plenum. So we can repurpose that space for a lot of different IT end user benefits. Operationally, zero impact to the design enhancements that we had already planned. So one of the things during our collaborative process was we took what we had designed that we were very happy with, we were actually able to implement some of those designs into the modular process. So when we threw $500,000 of design documents in the trash, we felt good about it, at least a little bit. Zero impact to our existing SLAs, reduced time for construction, obviously, provisioning costs, and reduced maintenance activities. We still haven't, we're collecting some data along these lines. We really haven't figured out that, but that's not part of that OPEX reduction. We're still in the process of seeing what that looks like financially. So, detriments. Well, over a dozen trips to Phoenix, and I still haven't played a round of golf there, but I'm planning on fixing that here pretty soon. One of the other things, we were very concerned with our customers' perception, and almost to the fact, or to the point of where we were hesitating on, really, is this going to be right for us? Because, you know, the traditional raised floor environment was working. We were filling space at a pretty rapid clip, obviously. We were getting ready to expand. And you know, at the end of the day, it turned out that that was the least of our concerns. I actually have more people wanting to move into the modular piece. The benefits that we've seen are, now we have an option where customers can take advantage of that technology. So, our new paradigm, our data center 2.0, and granted it's not fully modular because we have traditional raised floor, but that approach is now incorporated into our design process, construction process as we move forward. So our two phases will actually be all modular, data modules. We've actually increased the IT end user load by 5.2 megawatts, the majority of which was repurposing what we no longer need in cooling. So that reduction in PUE of 29%, we originally had 15 chillers that would have went in incrementally. We dropped that number by 6, and that's in an N+1 configuration. So, just a couple of pictures. These are our data modules inside our data center. Everything becomes modular. The raised floor you see there is because we had 150,000 square feet in stock. So we're still using the raised floor around it, but it's no longer an air plenum. We've actually seen, this is a picture inside the module of a customer that's doing big data analytics. Without going into too much detail, they can run a static load of 22 kW in 4 racks, cycle it up to 77 kW in 20 seconds. The heat load and the dynamics in the data modules are just well suited for that environment, or that actual application. But the funny thing we found is our customers are looking at all this ancillary space we've created, and we've put in test and turn up areas, customer drop-in areas, right around the data modules, storage areas. Something that you wouldn't have done in a traditional raised floor environment in an air plenum and such. So that's really caught on. So I'll end with a quote. What we believe is over the last few years, and I've been coming to the Uptime symposiums for many years now. And it really gives me an opportunity to talk to a lot of different people. And you go back to that first quote about a complex social process replacing a paradigm, and it's always better. That's part of this process. And we enjoy collaborating with folks, but it's really helped us getting through that process. Now, we're looking at a lot of different technologies now that we would have never looked at before. And I think once you get to that point, it opens up a lot of different opportunity. So, anyway, our motto is just keep evolving. I think it's great that the data center industry is going through this at this time. We're proud to be involved. And I guess I've finished quick enough to where I could probably entertain some questions. So thank you.
Wow. Yes, can you please share the dollars per kilowatt on this data center?
I can tell you in a range of what we reduced it to, but I'd rather not share the actual dollar amount. Yeah, but we've seen a 14% reduction in CAPEX on a per kilowatt basis.
What I understand is that, Robert, that you only using the modular portion of the data module. Is that correct?
Yes, currently.
Okay. So that is the part that is the modularized in the data center now.
Right, and that's why I said that we haven't completely adapted a completely modular build, but we're in the process of doing that. The data modules allowed us to, essentially start from the IT end user back. We already had some existing infrastructure in there, and I apologize, those lights are bright. And what we didn't want to do is completely redesign our back-end infrastructure, and we had some existing capacity. So we chose to adapt it to fit the data modules. Now going forward, we're looking at different plans for power modules, some other stuff we're looking at. And to be honest with you, getting through this process and getting comfortable with it, we're looking at stuff that we probably wouldn't looked at 1 or 2 years ago, believe it or not. So,
thank you.
Yeah. All right. Thank you. Thanks for having us.